So, what does the farm of the future really look like? You might picture sterile labs, maybe some flying robots, but you'd be surprised to learn that the blueprint for it, well, it isn't in some far-off tomorrow, it's actually buried deep in our distant past. We're about to uncover a perfect partnership, an ancient biological engine that we're only just now rediscovering.
It all starts with just one number, 90%. That's how much less water this system can use compared to the kind of farming we do today. Now, in a world that is running dangerously low on its most precious resource, a number like that doesn't just matter. It literally changes everything.
And here's the hidden truth most people just don't realize. Modern agriculture is one of the thirstiest industries on the entire planet. It guzzles about 70% of our available fresh water. It's a fundamentally broken equation if you think about it. We have to feed a growing world, but we're basically draining the well dry just to do it.
So to find the solution, we first have to wrap our heads around the true scale of the problem. We've engineered this food system that's incredibly productive, sure, but it's come at a steep and kinda hidden cost to our planet. If you look closer, you'll see every single drop of water is caught in this massive tug of war. You got growing cities on one side and our farms on the other. This isn't just a little pressure. It's a quiet crisis. It's a race to find a fundamentally smarter way to grow our food before the system breaks for good.
But what if the blueprint for a better way has been here all along, just hidden in plain sight? What if nature had already perfected a system that produces tons of food with practically zero waste?
It's called aquaponics, and at its heart, it's just a brilliant partnership. It takes fish farming and marries it with soilless plant cultivation. The result? A single, self-sustaining loop where the two don't just coexist, they thrive because of each other. Now, don't just see this as some diagram. See it for what it truly is, the schematic for a perfect biological engine. An engine designed by nature and perfected over millennia. The only input is fish feed, and the only exhaust is food.
The whole process is beautiful in its simplicity. First, the fish do what they do best. They eat and they produce waste. That waste is rich in ammonia, which is actually toxic to them. But in this system, that waste is basically gold. See, tiny beneficial bacteria get to work, converting that toxic ammonia into nitrates, which is a 5-star meal for plants. The plants then soak up these nutrients, and in doing so, they filter and purify the water, sending it right back, perfectly clean, for the fish. It's a perfect symbiotic loop.
And here's what most people don't realize. Hydroponics is brilliant tech, but it's totally dependent on a constant supply of manufactured chemical fertilizers. Aquaponics, it creates its own premium organic fertilizer for free. The fish are a living fertilizer factory running 24/7. This also means no pesticides, ever. You can't use them without harming the fish, which gives you this incredible side effect, perfectly clean produce.
So it sounds like the perfect system, right? A self-fertilizing, water-saving food machine, and this is where things get really interesting. Because you have to ask yourself, if it's so perfect, why aren't these farms everywhere?
That's the crucial question, isn't it? And the answer is that running one of these systems isn't just farming. It's more like conducting an orchestra of living things, and every single element has to be in perfect harmony. Let's just zoom in on one key challenge, the nutrient gap. Turns out the free fertilizer from fish isn't always a complete meal. Take a look at phosphorus. For a fruiting plant, let's say a tomato, you want about 40 to 60 milligrams per liter. But a typical aquaponics system, it might only provide somewhere between 1 and 17. Now, that gap is the difference between a good harvest and a great one, and it requires some pretty careful management to solve. And that's really just the beginning. The grower has to become a chemist, constantly managing pH levels. They have to be a fish biologist and a botanist, all at the same time. The initial cost can be high and is a really steep learning curve. This isn't some plug-and-play solution. It's a craft that requires real skill to master.
For decades, these challenges kept aquaponics as a niche thing for dedicated hobbyists and a few researchers. But now, technology is stepping in to solve that balancing act, upgrading this ancient wisdom for the 21st century.
This is the next evolution. It's the fusion of that perfect biological loop with the precision of modern technology. Think of it as giving nature a smartwatch.
This changes the game completely. Instead of a farmer running around with the test kit, you have an automated ecosystem. Smart sensors are the new nervous system, monitoring pH, temperature, and nutrients in real time. They can automatically dose the water, trigger fish feeders, and maintain that delicate balance with a precision a human simply can't match. The art of farming is becoming an exact science. This kind of smart aquaponics is part of a much bigger idea, controlled environment agriculture, or CEA. This is all about growing high-value crops inside greenhouses and vertical farms right where people live. It gives us total control over the growing conditions for maximum yield and incredible efficiency.
And the beauty of these systems is just how scalable they are. They can be small enough for a backyard or massive enough to feed an entire neighborhood. By bringing the farm into the city, we can have fresher food with a tiny transportation footprint. It's a revolution in local food production happening right now.
So we've journeyed from a fundamental problem to an ancient solution and finally to a high-tech upgrade that could very well redefine how we feed ourselves.
This quote really captures the essence of it all. This isn't just a clever piece of engineering. It's a system built on mutual support and zero waste. A model for how we can work with nature, not against it. It really is a hopeful vision.
So, what's the ultimate takeaway here? We face enormous challenges in feeding our planet sustainably. Aquaponics isn't a single magic bullet, of course, but it represents a powerful shift in thinking, working with nature's genius instead of fighting against it. Which leaves us with one final fascinating question. Could the secret ingredient in your next salad be a fish?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.